My name is Kylie, and I've been taking the programming course this semester and have just learned so much about the different programs we use, different platforms we use to create programs for certain things. Throughout the semester, we learned programming of Arduino is the most recent one. We learned Python, we learned LabVIEW a little bit, I think, or it might be overlapping with another class, C+, and MATLAB. So in each of those, it's a different type of program, a different type of language that you have to learn and you have to be able to use. But for our final project, robot project, we were asked to use Arduino. Arduino can be a little complex in the coding. It's just a lot of coding and different things we need to use. It's used through an Arduino board. There are many different types. You have a Nano, which is like this big, and it can be, we plugged it in to a bigger Arduino. Actually, the one you'll see on our thing and our little blue one. But that's a little bit about the background. Let me tell you about our robot we created. So we had the option of choosing a line follower, obstacle avoidance, and a few others. Due to me having previously done line following, torque pulling, or tractor pull, and a speed race, I chose obstacle avoidance because I had not yet done something with obstacle avoidance and wanted to try it out. So this is what we built. Give you a 360, the front, side. This is the under, so I'll tell you all about everything I had to use, and then the top. So to start off, we put our motors on, and then as we were working throughout on this motor, our black wire, which you can see it right there, because I fed them through here. We do not have a black wire, so this motor will not work, and you'd have to solder it on. Have to open it up and resolder it. It's a whole ordeal, and I didn't have my solder gun. And then we have our ultrasonic receiver, so it shoots out waves, and say you're like this far in front of me, it shoots it out, it sees you, it's going to reverse and go this way. So that's how we are making our obstacle avoidance. You can set the range to 5 meters, 10 meters, however much you can go. I can't remember the limit on it, but I know it can't exceed a certain limit, so if it's like really far, it won't notice it. So that's that, and then that's connected into our Arduino is right here. This is our expander. So as you can see, it is put into the female heads, or the heads are going in. And then this is where all our wiring takes place. And so this is wired into here. And then also wired into here is our receiver for our remote that would control it. So there's that. And then also we have our motor driver. So this is connected to this, where all our code comes from and where everything is put out. As you can see, it's already falling apart. So that's a connection to the motor board to the Arduino. Anyway, so this is what drives these two. And then to power all of this, we have our battery pack, which I do not have batteries as well. That'll fit this. So that's all of this entails. So a little of the problems I faced while creating this project was I ran out of screws very fast that fit. So I had to duct tape my ultrasonic thing on here, duct tape, zip tie, because I ran out of screws, and these screws are as tiny as possible. So that's a problem. Obviously, I told you about the wire was a big issue, because then I can't drive my motors. This motor won't have power. So another thing I ran into was just the cuts on this pre-cuts on this board did not line up with a bunch of the circles where a screw should go on this, so it's kind of catty-wonkered. And then also this did not fit either, so it's glued onto 2 screws. And then to balance it, I found this, I don't know what I was like, I need something that fits the width that'll stay on. So this is hot glued on and holds this up. So this is moving, and this just has no motor. It just allows it to guide a little bit better. So overall, that's my project. I wish it would work, but there's a lot of factors rolling into this kit that wouldn't work. So I would recommend a different kit maybe, or just being a little more easier on your kit. But I just feel like you have to be able to maneuver wires, and that it came out so easily was kind of scary. So the last thing you would do in this is this receiver. You'd plug it into your computer with your code, and you would apply your code on here, and then you'd be able to, there's a button right here, press that button and the code would run. So what would happen is we'd be driving. We also have a remote so we can steer it. We'd be driving, say there's a wall here, oh, it's gonna stop, reverse one side to be able to turn. And that's essentially what our code does, essentially what our robot does. So that is my project for our final. I hope you enjoyed, and thank you for watching.